Hello friends, welcome again to this channel. This is G Solutions. We find solutions for your needs. Again, let us have this problem involving the phase voltage and phase current. Here, value for the phase voltage, which is 220 sine omega t plus 210 degree, and the current is 10 sine omega t minus 180 degree. Okay, so we can actually use many techniques in solving this problem, and one of that is we are to represent this given values into a phasor representation in your xy plane. Okay, so if you are to have the phasor representation of this one in xy plane, so which this part is the reference, the angle for your voltage is omega t plus 210 degrees. So we take this angle from this point here in our x-axis, positive x-axis, and rotating it from this point to have the angle of 210. We do it counterclockwise, and your B will maybe be in this part. Okay, so that is from this point up to this one, and that is 210 degree. So this is your B phase. Okay, B phase, and the other one is 180 degree. So that is 180 degree. It just simply as can be situated here. Okay, so that is 180 degree. From this point up to this point, this is 180 degrees. So this is your I sub P. Okay, so but since we are to get the theta is actually the subtraction of the angle generated by your voltage and the angle generated by your current. So that is 210 minus 180 degrees. So this will be your theta here. So theta is actually equal to 30 degree. And using now the formula, which is P is equals to 3B phase times I phase cosine theta, which is our power factor. So we just simply substitute our values. So 3BP is 220. Okay, that is the BP, and your I sub P is actually 10. This I sub P, so this is 10. And again, the power factor angle is theta, which is 30 degree. So if you have your calculator, you just directly press your calculator. It will give you 5715.76. Okay, this is in watts. Okay, so this is how you do the solution of this problem. You can also do this one. You represent this into a phasor form. Phasor form in the sense that we use the polar form of this value. So that will become B 220 cis of, we place the angle here, 210 degree. And for current also, you have 10 cis of negative 180 degree. And if we are looking for the power of the system, we just simply multiply B times I. So the power of the system will be actually, since that we are dealing here with three-phase system, the formula here will be 3, okay, and because we are dealing here with 3 single phase, so you multiply it by 3, and each one of these has its own angle, so it will be more expanded in this formula if I write like this one. 3 times B, which is 220, cis of 210 degree, I mean, times 10, cis of negative 180 degree. Okay, so you just multiply 3 times 220 times 10, and it will give you 5. Okay, so you multiply, I mean, that's not 5, but this one, 3 times 220, okay, times 10, okay, that is 6,600. Cis of 210 minus 180, you add the angle, and it will give you 30 degree. Okay, so and actually the power in just simply multiplying this one, actually this is an apparent power S, okay, and multiplied by that one, 3 times B and I. So therefore, the value for our apparent power is 6,600 cis of 30 degree. Now, if we are going to get the rectangular value of 6,600 cis of 30 degree, so you'll have this value, rectangular, 6,600, comma, 30. Okay, and that is 5,715.76 plus, and the alpha of F, which will be our reactive power, which is J 3,300. Okay, so since this is of the form S is equals to P plus JQ, okay, so therefore our result is this one. This will be the power of the system. So when we mean the power of the system, since it is not stated as it can as a reactive or apparent or real, you always take it as the real power. So that is 5,715.76. So this is how you solve this problem. Okay, there are many ways in our saying our saying says that there are many ways in killing a cat. Isn't it? You can kill a cat by using a gun or a sword, or you can kill a cat by using a nuclear bomb. But never use nuclear bomb, because all of us will die. So it's much better for us to get the most appropriate technique in solving a problem. So thank you so much for watching this video.